today's video, we're looking at rules in inequality. Now, we treated a video already on inequality where we saw many things in inequality. One of which we saw inequality in one variable, two variables. We looked at the graph, we looked at the representation on number lines, and so on. Now, today we'll be looking at some few rules that you need to know in inequality, for you to answer some other questions related to inequality. Now, for A, B, C, D, and X, all coming from real numbers, that is, if A, B, C, D, and X are all real numbers, I'll be using all this to, test my rules. Now, A is said to be greater than B implies that what? A minus B is positive. What do I mean by positive? It means A minus B must be greater than what? 0. Just from this point, if A is greater than B, bring B here, it means A minus B is greater than what? 0. It means it is positive. Now, also, A is less than B implies that what? A minus B is what? Negative. Which is what? A minus B is less than what? 0. So, when this one comes here, it becomes minus B, which means it is negative. I'll get negative value in that case then. So, now number two, for, this is like, just like, okay, this is like number 1A, this is 1B in that case then. I have to test for X. For X element of real numbers, it implies that when A is said to be greater than B, A plus X must be greater than B plus X. Okay? Also, A minus X must be greater than what? B minus X. And when A is said to be less than B, it implies that what? A plus X also must be less than what? B plus X. And A minus X must be less than what? B minus what? X. So, how do you test that this is correct? Very simple. Just pick arbitrary values of your A, B, and X in this case and test for it. Now, if my A is 2 and my B is 3, then my X is 1. What will I do here? So I'm going to have 2 plus 1, that's 3. It must be great. Okay, A is greater than B, isn't it? So it means this must be 3. This must be 2. So if A is greater than B and A is 3, B is 2. If A is less than B, it means that what? A can be 2, B can be what? 3. So it means 3 plus 1 must give us 4, and it must be greater than what? 2 plus 1, which is what? 3. 3 minus 1 will give us 2, which must be greater than what? 2 minus 1, which is 1. For this case also, 2 plus 1, 3, is less than what? 3 plus 1, which is 4. 2 minus 1 is 1, which is less than what? 3 minus 1, which is what? 2. Now, that is relatively the proof. Now, for number 2 rule, for X element of set of real numbers in this case, A is said to be greater than B if AX is greater than what? BX. That is, if I multiply X by A and multiply X by also B, it's said to be greater than BX where my X is what? Positive. If my X is greater than 0, any value of my X which is greater than 0, when applied to this equation, I must get a positive result. So, also, AX is less than BX where X is what? Negative. Okay? So, if A is greater than B, if A is 3 and B is 2, as we're using, and then we have our X to be positive, that's plus 1. It means I'm going to have this as what? 3 equals 2. But if I have my X to be negative, that's minus 1. This becomes minus 3 is less than what? Minus 2. And that's actually correct. So that's like the proof of that. Also, if A is less than B, it implies that AX will be less than BX, where my X is what? Positive in this case. So this rule will follow this rule, when applied directly. And then also AX will be what? Greater than BX, where my X is what? Negative. So to test this one, it means when my a is 2 and my b is what? 3, my x is still 1. X positive means my x is 1. So I'm going to have this as what? 2 less than 3. X negative means minus 1. This becomes what? Minus 2 greater than what? Minus 3, which is still correct. Number 3 rule, we have a is said to be greater than b and c is said to be greater than what? D if a plus c is greater than what? B plus D. This is greater than this and this is greater than this if this plus this is greater than what? This plus this. Now, this works for only this. It does not work for a minus c less than b minus d. It does not work for this. Why? Because if you try something like 5 greater than 4 and 5 greater than 4 and say 3 greater than 2. Now 5 plus 3 is 8, 4 plus 2 is 6. 8 is greater than 6, very correct. But 5 plus 3, 5 minus 3 I mean, is 2. 4 minus 2 is 2, which 2 is not greater than 2, you know, or 2 is not less than 2 in that case then, in this case. Hope you understand. So it always works for this, it does not work for this. Number 4, the fourth rule we have is what? A is said to be greater than B and B is said to be greater than C if A is greater than what? C. This is like a symmetric relation. So we have A greater than B, B greater than C, then A must be greater than what? C. A equals B, B equals C, A is equals to C. So similar to all we have, you can test for it and then prove that it's correct. Number 5th rule is what? A greater than B and C greater than B for all A, B, C, and D to be positive. If A, B, C, and D are positive, this is greater than this is greater than this. What then happens? Now, what happens is that A times C must always be greater than what? B times D. And A over D must always be greater than what? B over what? Over C. If A is greater than B and C is greater than D, I mean, for all A, B, C, D to be positive, you know, A times C must be greater than what? B times D, just as we did the positive in number 3 rule. So A times B must be greater than what? C times D. A times C, I mean, must be greater than what? B times D, as A over D must be greater than what? B over what? Over C. So that's that about that. You can test it to see that it is correct. Then finally, A is greater than B, you know, where my A and B are what? Are both positive. If my A and B are positive, A is said to be what? Greater than B. What then happens? It implies that what? A square must always be greater than what? B square. A cube must always be greater than what? Must always be greater than what? B cube. And so on. A raised to power 4 must be greater than B raised to power 4. Also, 1 over A must be less than 1 over B. 1 over A squared must be less than what? 1 over B squared. 1 over A cube must be less than 1 over what? B cube. And so on. That's that about that.